Installing a switch outlet in a bathroom to control a table lamp presents some challenges related to ground fault circuit interrupter (GFCI) protection. The primary concern arises from the fact that bathrooms are considered wet locations, necessitating GFCI protection for all receptacles. This is mandated by electrical codes to prevent electrical shock hazards. The idea of placing a switched outlet on the load side of a GFCI, while seemingly a way to avoid tripping the GFCI when switching, can actually introduce complications and may not be code compliant. Let's explore why this approach might not be ideal and discuss alternative solutions. Firstly, understanding GFCI operation is crucial. A GFCI constantly monitors the current flowing to and from the connected circuit. If it detects an imbalance, even a very small one, typically around 5 mA between the outgoing and return current, it interprets this as a ground fault. This means that some current is leaking out of the intended circuit, potentially through a person who is in contact with a grounded object. When a ground fault is detected, the GFCI instantly trips, cutting off the power to the circuit and preventing a potentially fatal shock. Now, considering the scenario of placing the switched outlet on the load side of the GFCI, several issues can arise. One issue is nuisance tripping. Although the intention is to prevent tripping, the act of switching the outlet on and off can sometimes create transient voltage spikes or imbalances in the circuit. These transients, even if brief, can be misinterpreted by the GFCI as a ground fault, causing it to trip unnecessarily. Secondly, code compliance is a significant concern. Electrical codes, such as the National Electrical Code, NEC, have specific requirements for GFCI protection in bathrooms. Generally, all receptacles in a bathroom must be GFCI protected. While placing the switched outlet on the load side of a GFCI does provide a form of GFCI protection, it may not meet the intent of the code, particularly if the GFCI is located remotely or if the wiring configuration introduces other potential hazards. In some jurisdictions, electrical inspectors may not approve this type of installation. Thirdly, potential for miswiring is a consideration. When working with GFCI circuits, it's essential to ensure that the wiring is correct. If the load and line sides of the GFCI are reversed, the GFCI may still function, but it will not provide the intended protection. In the scenario of a switched outlet on the load side, there is an increased risk of miswiring, especially if the installation is not performed by a qualified electrician. A miswired GFCI can create a false sense of security and may not protect against ground faults as intended. Fourthly, future maintenance and troubleshooting can become more complex. When the switched outlet is placed on the load side of the GFCI, it can be more difficult to diagnose and repair electrical problems in the future. For example, if the GFCI trips frequently, it may be challenging to determine whether the problem is with the GFCI itself, the wiring to the switched outlet, or the appliance plugged into the switched outlet. The non-standard wiring configuration can also confuse future electricians who may be unfamiliar with the installation. Given these potential issues, let's explore some safer and more code-compliant alternatives for installing a switched outlet in a bathroom. One alternative is to install a standard GFCI protected outlet and use a separate switch to control a light fixture instead of the outlet. This is the most straightforward and often the preferred method. The GFCI outlet provides protection for any devices plugged into it, while the switch controls a dedicated lighting circuit. The switch can be a standard wall switch or a dimmer switch, depending on the desired lighting control. To implement the solution, firstly, install a standard GFCI outlet in the desired location. Ensure that the outlet is properly wired according to the manufacturer's instructions and local electrical codes. Secondly, install a separate junction box for the switch. The junction box should be located in a convenient and accessible location, typically near the entrance to the bathroom. Thirdly, run a new cable from the junction box to the desired location for the light fixture. The cable should be sized appropriately for the expected load of the light fixture. Fourthly, connect the switch to the cable following the manufacturer's instructions and local electrical codes. The switch should interrupt the hot wire to the light fixture. Fifthly, connect the light fixture to the cable, ensuring that all connections are secure and properly insulated. Another alternative is to use a combination GFCI outlet and switch. These devices combine the functionality of a GFCI outlet and a switch into a single unit. They are typically designed to be installed in a standard electrical box and can simplify the wiring process. To implement this solution, firstly, purchase a combination GFCI outlet and switch that is rated for the intended use. Ensure that the device is approved by a recognized testing laboratory, such as Underwriters Laboratories, AL. Secondly, install the combination GFCI outlet and switch in the desired location. Follow the manufacturer's instructions for wiring the device. Typically, the device will have separate terminals for the line, load, and switch connections. Thirdly, connect the line wires to the line terminals on the device. The line wires are the incoming power wires from the circuit breaker. Fourthly, connect the load wires to the load terminals on the device. The load wires are the wires that feed the switched outlet. Fifthly, connect the switch wires to the switch terminals on the device. The switch wires are the wires that control the light fixture. Another approach is to install a standard GFCI outlet and use the plug-in lamp with a built-in switch. This option eliminates the need for a separate switch and can be a convenient solution in some cases. To implement this solution, firstly, install a standard GFCI outlet in the desired location. Ensure that the outlet is properly wired according to the manufacturer's instructions and local electrical codes. Secondly, purchase a plug-in lamp with a built-in switch. The lamp should be rated for the intended use and should be approved by a recognized testing laboratory. Thirdly, plug the lamp into the GFCI outlet. The built-in switch on the lamp will allow the user to turn the lamp on and off as needed. When selecting a GFCI outlet, it's important to choose one that is appropriate for the intended use. GFCI outlets are available in various amperages, voltage ratings, and trip levels. The amperage rating of the outlet should be sufficient to handle the expected load of the devices that will be plugged into it. The voltage rating of the outlet should match the voltage of the electrical system. The trip level of the GFCI outlet refers to the amount of current imbalance that is required to trip the device. Standard GFCI outlets typically have a trip level of 5 mA. When installing a GFCI outlet, it's important to follow the manufacturer's instructions carefully. GFCI outlets have specific wiring requirements, and incorrect wiring can prevent the device from functioning properly. It's also important to test the GFCI outlet after installation to ensure that it is working correctly. To test a GFCI outlet, press the test button on the device. The outlet should trip, cutting off the power to the circuit. If the outlet does not trip, there may be a wiring problem or the GFCI outlet may be defective. In addition to GFCI protection, it's also important to ensure that all wiring in the bathroom is properly grounded. Grounding provides a safe path for fault current to flow back to the electrical panel, which helps to prevent electrical shock hazards. All metal enclosures, such as junction boxes and light fixtures, should be properly grounded. The grounding conductor should be connected to the grounding terminal on the GFCI outlet and to the grounding bus bar in the electrical panel. When working with electrical wiring, it's essential to follow all safety precautions. Always turn off the power to the circuit before working on any electrical components. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and rubber gloves. If you are not comfortable working with electrical wiring, it's best to hire a qualified electrician to perform the work. In summary, while the idea of placing a switched outlet on the load side of a GFCI may seem like a way to avoid nuisance tripping, it can introduce complications and may not be code compliant. Safer and more code-compliant alternatives include installing a standard GFCI protected outlet and using a separate switch to control a light fixture, using a combination GFCI outlet and switch, or installing a standard GFCI outlet and using a plug-in lamp with a built-in switch. Always follow all safety precautions when working with electrical wiring and consult with a qualified electrician if you have any questions or concerns. Remember to consult local electrical codes and regulations, as they may vary depending on your location. Adhering to these codes ensures the safety and compliance of the electrical installation. Consider the specific needs of the customer and the layout of the bathroom when choosing the best solution. Proper planning and careful execution are essential for a safe and functional electrical installation.